Hello everyone. In this video we are going to look at differentiation and covering almost every part under differentiation. Just to know, by the end of this video you'll be able to answer almost every question that involves differentiation. Now let us look at this. Mostly when we look at differentiation, what comes to our mind is an expression in form of powers. Now, for example, if you are given y is equal to x power n, we know that its derivative, dy dx, is equal to n, then x power n minus 1. Now, that is the general formula, meaning that for any function y equaling to fx and x is having a certain power, we have that dy dx equaling to, now we put a prime or a dash up, is equal to n times the x, and then we reduce the power by 1. So that is the general definition of differentiation. So after, let us look at the methods. So one, we shall look at what they call chain rule. Chain rule works like if you have if y is equal to fx, just use a function, is equal to maybe any function 2x plus maybe a constant. It can be 2x only, then power n. Then by chain rule we say that the derivative of y will be equaling to, we drop the power n, then we multiply by the original function 2x, then we reduce the power by 1, applying the same format we had up, then we multiply by the derivative of the what is in the bracket, the derivative of this one, yes, and then that will be 2x plus k. Then after that, this is the general formula for chain rule, or maybe you can simplify it as n times 2x plus k, then times the whole of this function. Maybe you can call it, anyway, you can just leave it, then the derivative of 2x plus k, then the derivative, you can just put prime, maybe it's what the derivative is. So that is the chain rule. The next, let us go to what they call product rule. Product rule. This one works like if you are given two functions, y is equal to fx, then g of x, then the product rule works right. The derivative of y dx is equal to, we divide this one in terms of constants, we call this one, then call this one v. So dy dx, the general formula is u, then times the derivative of v, times the derivative of v, then plus v times the derivative of u. Now if we just substitute in, that we are going to get f(x) times v, of which v is the g of x with the derivative, then plus v, which is g of x times f of x and the derivative. Now we can see it. Then the next one will be, let us look at what we call the product rule. The product rule, yes, it's complete. Now we'll go to the next one, which is the quotient rule. The next one is the quotient rule. Quotient rule also works on two functions, in that there must be maybe fx and gx. Now let y is equal to fx divided by g of x. This one can be put in the form of u divided by v. So the quotient rule works that the dy dx will be equaling to, now let us just use u and v. You get v times the derivative of u minus u times the derivative of v, then divided by the square of v, of which v is the denominator function. Meaning that for this case, it is going to be v was g of x times f of x with the derivative minus u of x, which is f of x times g of x derivative, and divided by g of x, then the whole will be squared. Isn't it? So this is the quotient rule. Okay, let us go to the next part. The next part is the exponential differentiation. Exponent, I think you know about it. So here we always have that if y is equal to e of x, majorly this is the starting or the basic. We have that the derivative of y will be equal to ex. This is the basic for exponential differentiation. Then others will originate from this one of e of x. Now, if you have y is equal to e power a function of x, now the derivative will be d of y dx is equal to, we drop the function and differentiate it, so it will be d dx of the function up times, we just replace the whole exponential and its function, or someone can have it in the form of d y dx equaling to y derivative is equal to the function of x times e power f x. That is just the exponential differentiation, as it is summarized like that. So this, now let us see how do we differentiate the natural logarithm. I know you have ever met it, that if you have y is equal to 1 is equal to is equal to 1 over x. Here we believe that the power, you'll see that if you have y is equal to x, its derivative will be the dy dx will be equaling to, here it becomes 1 out of x. At least this is the best. And then it results into the format like the if y is equal to real fx. So for this one, generally it just results into dy dx is equal to, we get the derivative, we put it up of the function, then divide by the original function, which is fx. That's it. That's it. For example, if you have if y is equal to x squared, then we get the derivative of y is equal to differentiate to this one, which will become 2x divided by x squared, and then the answer becomes 2 divided by x. So that's how we solve it. Now, also we have other function that results into natural logarithm or logarithm. For example, if you have that y is equal to a power x. Now, from this one to differentiate it, or we always introduce the natural logarithm. Introduce natural. So from here we shall get in y is equal to a power x, and then differentiate both sides. Here it will be x in a, and then here differentiate both sides. So it will become 1 over 1 is equal to, of course, this one is a constant, and then we just with that constant, which will just be in a. But since y was respect to x, so we shall have there what we call dy dx. So for us, we are aiming at getting dy dx, so we shall have dy dx is equal to, we multiply y on the right hand side to be y, then in a. But what is y? But y is equal to a by x, implying that we shall have dy dx would be equal to y, which was a by x times a x. And thus it generally continues like that. If y may be equal to ax, it will always be like that. For example, e.g. find y derivative for y is equal to x. So we have already seen that from up here, that y is equal to 5 power x, 8 times 0. So that's how we solve the differentiation. Now, at least I believe in this video you have learned almost all the concepts. So don't forget to leave a comment or a like, such that in the next video where I will be tackling the trigonometrical differentiation, we can cover it, or continue and catch up with me on the main part or the part that you wish to learn more. Then I'll be able to